All right, so with quadrilaterals and coordinate geometry, the first thing I want to do is I put up there the flow chart. Okay, this is the quadrilateral family tree. Like you've seen this a million times, right? In terms of all quadrilaterals have 4 sides, and then we have specific ones. We have parallelograms, trapezoids, and kites. Okay, so just kind of keep this in the back of your mind, how they all relate. And we did that a lot in this last chapter. I also gave you a couple of reminders here in the next 2 sections as far as properties of each of those quadrilaterals. So quadrilateral we know just has 4 sides. A kite is going to have 2 sets of consecutive congruent sides and no parallel lines. Trapezoid has exactly 1 set of parallel lines. Your isosceles trapezoid is going to be that 1 set of parallel lines and the legs are congruent, right? Okay. Then when you look at parallelogram, you have 2 sets of parallel sides. A rhombus is parallelogram with 4 congruent sides. A rectangle is a parallelogram with 4 right angles. And then your square has the parallelogram plus 4 congruent sides, 4 congruent angles, right? Okay, so basically those are your basic definitions, and that's going to be key in determining what kind of quadrilateral we're looking at. So basically what's going to happen is we're going to have 4 points, we're going to graph them, and we're going to determine what kind of quadrilateral it is. So before we get into graphing and all that kind of stuff, what I've done here is we have this quadrilateral named ABCD. Right? So whatever it may look like, wherever it is on the coordinate plane, it's 4 points, ABCD, remember, go in order, right? So what I want you to notice, I've set up this table for you, and ultimately you're going to create a table like this. But what we're going to do is we're going to look at data and determine what kind of quadrilateral it is, and then we're going to add in the fact that you're going to have to create this own table, your own table. All right, so I have some information here about quadrilateral ABCD. I've given you the slope of all 4 sides, and I've given you the length of all 4 sides. Now, notice I have AB and CD listed first, or listed together, right? AB and CD. I did this on purpose. I listed the opposite sides together because if I can look at slopes, I can determine if opposite sides are parallel or not. Right? So I've listed it in order so that opposite sides are listed together. So let's look at slopes. So if the lines are parallel, remember the slopes have to be the same. So are AB and CD parallel? Yes. What about BC and AD? Are they parallel? Nope, so they're not the exact same number, right? Okay, so how many sets of parallel lines do we have? 1 set of parallel lines. So we have it narrowed down to some sort of trapezoid, right? Because it only has 1 set of parallel lines. Now I need to look to see if these lines are parallel, if these 2 lines are parallel, I need BC and AD to be congruent for it to be an isosceles trapezoid. So are AD and BC, are they congruent? Are AD and BC congruent? Are they the same length? We have the square root of 26 and the square root of 34. They're not the exact same number, right? So they're not congruent. Okay, so this is just a trapezoid. All right, so let's do it again. Let's follow that process again. So let's look at opposite sides, AB and CD. All right, if you need to, sketch yourself a little picture. AB and CD, are the slopes the same? Do we have any sets of parallel lines? We do not have any parallel lines this time, right? So it's either got to be what or what? If there's no parallel lines at all, that means it can't be a parallelogram. It can't be a trapezoid. So it's either got to be a kite or just a plain old quadrilateral, right? Nothing special. Okay, so let's look. Side lengths. AB we know is the square root of 34. CD is the square root of 58. BC is the square root of 34. and AB is the square root of 58. So based on those numbers, do we have a kite? Do we have consecutive congruent sides? We do, right? So this is a kite. Is that okay? All right, next one. Okay, so again, I have my opposite sides listed together. So, do we have any parallel sides? Yeah, how many sets of parallel lines? We have 2 sets, right? So it has to be a parallelogram of some sort. Okay, so now, because it's a parallelogram, we got to figure out, do we have congruent sides? Do we have right angles? So first of all, are all 4 sides congruent? They're not, right? Because they're not all the same number. So it can't be a rhombus, it can't be a square. We need to know, is it a rectangle? Is it a rectangle? So if it's a rectangle, that means it's going to have a right angle, right? Okay, so we need to see 2 sides that intersect. 2 sides that intersect. So CD and BC are going to intersect. If they are going to be forming a right angle, they have to be perpendicular, which means they have to be the opposite reciprocals. So are 0 and 2 opposite reciprocals? No, so we don't have a right angle, which means it's just a plain old parallelogram. Is this making sense? Kind of. You're going to get lots of practice. All right, so let's look at the next one. Let's look at the next one here. So do we have any parallel lines? Yeah, how many sets? 2 sets, so I know it has to be a parallelogram, right? Okay, do we have 4 congruent sides? Yes, so it either has to be a what or a what? A rhombus or a square. It could either be a rhombus or a square, right? Either got to be a rhombus or a square. So we need to figure out, does it have the right angle? So are these 2 opposite reciprocals?
Yes.
No, if they're opposite reciprocals, it'd be 2 and negative 1/2. Right? We had to flip the fraction too. So they're opposite signs, but they have to be the reciprocal as well. So we don't have a right angle, which means it can't be a square. So it's got to be a rhombus. All right, so let's think about how I made this table. All right, let's think about how I made this table every time. So AB and CD, those are just opposite sides listed together, right? And the next 2 are just the other opposite sides listed together. The slope, we either have a slope formula, or if you graph it, you could just count rise over run. How did I find the side length? Distance formula. Okay, the distance formula. Every time the distance formula. Okay, now it's horribly tedious. Okay, so I'm going to teach you how to do it on Desmos. So if you have your Chromebook or sit next to someone who has a Chromebook, pull it out. And I want you to go to desmos.com. Once you get there, you can just click on Graphing Calculator.
As long as you guys can see, I'm good with it. All right, so when we're going to use the distance formula, we always have two coordinates, right? Point 1 and point 2. So what we're going to do in Desmos, we're going to tell it to find the distance between 2 points. So what you do is you type the word distance. So D-I-S-T-A-N-C-E. And as you type it, it looks kind of goofy. Like it'll start spacing it. Like it'll go dis and then tan. But once you get the distance, it fixes itself. And you're going to start a parenthesis. So you can make up any 2 points you want. But I'm going to start another parenthesis, and I'm going to put my first point in. So let's say I pick the point 2, 3. So I'll put 2, 3. Close your parenthesis. So that's my first point. Then I put a comma, and then name my second point. So I'll just do like -5, 1. Okay? And you can see, like, you don't even have to close those two parentheses, and it's already giving you the length of that segment, or the length between those 2 points. So in this case, it's 7.28 for me. For whatever you typed in, it might be different, right? But we can use Desmos and the distance formula in order to find the length of each side. Make sense? All right, so here's what we're going to do. Everybody okay with the syntax of how to type it in and everything? I have it listed on your notes as well here. X1, comma, Y1, and then another comma between the points and the next two Y2. All right, so what we're going to do is we are going to name this figure. Okay, so first, let's plot our points. Let's plot our points. So we know A is at -4, 1. B is at 2, 4. C is at 1, 0. And D is at -5, -3. All right, so we want to list our opposite sides together. So AB and CD are opposite of each other. And then we have BC and AD. So for each of these, I need to calculate, oops, sorry. For each of these, I need to calculate the slope and the length of the side. All right, so again, you can use your slope formula if you want. Honestly, I can probably do it faster just doing rise over run, like counting it on my graph. It's up to you, but we need to find the slope of AB. I went up 3/6, so my slope is 3/6 or 1/2, right? For AB. How about CD? I got 3/6 again, or 1/2. All right, let's do BC. I got a +4, right? 4/1 or just 4. And then for AD, I went up 4/1, so it's 4 again. So even before we get to the length, what kind of shape is this going to be, at least? A parallelogram of some sort, right? Because we have two sets of parallel lines. Okay, let's look at our two intersecting sides. What about our slopes here? We have 1/2 and a 4. So are we going to have a right angle? No. So it's either got to be a rhombus or a parallelogram, right? We could probably guess, but we're going to calculate to double check, okay? Because it doesn't look like a rhombus, does it? Like the sides clearly look different lengths, but let's just verify it. Okay, so let's go to Desmos. All right, so side AB, got to turn on my light so I can see here. So once you have this typed in, you can just go in and edit your points. So I'm going to type in point A is -4, 1, and B was at 2, 4. Did you guys get 6.7? Are you okay with that? All right, so I had 6.7. All right, we can do the same thing. How about you guys start working through, how about these two tables here, you guys do CD. You two tables, you guys calculate BC for me. And then this side room, you guys do AB. Find the length of those segments. Do you have enough time for your point? Okay, how about CD? What did you guys get? So you have 6.7 again? Okay, how about BC? Yeah, 4.1. Is that okay with everybody? Okay, how about AD? I got 4.1. So we confirmed it's a parallelogram, right? But because we don't have 4 congruent sides, we know it's not a rhombus or a square. We already know it's not a rectangle. So this is just a plain old parallelogram. Does that make sense? If you can build the table right, it's fast and easy. You don't have to, I don't feel like you have to think real hard. All right, last one. Let's try the last one here. So go ahead and plot your points. Okay, so I'm going to build my table. We have AB and CD together, and then we have BC and AD together. We need the slope and we need the length. So let's break up the work here. You guys are going to find the slope of AB. You guys are going to find the slope of CD. You guys find the slope of BC. You guys find the slope of AD. You guys find the length of AD. Yep, you guys find the length of CD. Once you guys have your part, just send somebody up to write it in.
Good job. Okay, so line here. All right, so the only thing I take issue with is this one here. CD should be negative because it's going downhill. And then that's an uphill, so good. All right, so do we have any parallel lines? Well, let me give you a second, write those all down. So, sorry, all outside of there. Do you have enough time? Okay, so do we have any parallel lines? How many sets? One. So what kind of shape does it have to be? A trapezoid. So now we just have to figure out, is it an isosceles trapezoid? So we know these two sides are parallel. So are these two sides congruent? Yes, they are. So what kind of shape is this? An isosceles trapezoid. Is that okay? All right. So for your homework, I have 6 problems for you. All right, so I do expect you to graph them. I do expect you to create a table of some sort. Otherwise, you can't really confirm your answers. Okay, and then name whatever figure you think you have. Good? All right.